Hey guys, today we're going to work on something very important in geometry, triangle congruence. Now basically, we're going to use important vocabulary words and definitions from geometry to get triangles congruent. And basically, you got to focus on three things in each problem. When you're trying to get triangles congruent, let's say triangle ABC and triangle DEF, it's not necessary to get all 6 parts of triangle ABC congruent to all 6 parts of triangle DEF. The 6 parts I'm referring to, of course, are the 3 sides and the 3 angles. Mathematicians have determined that if you just get the sides, SSS stands for side, 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 the 3 sides of triangle ABC congruent to the 3 sides of triangle DEF, then those triangles are congruent. Or SAS stands for side, angle, side. It could be a side followed by an angle followed by a side of triangle ABC is congruent to a side, the corresponding side, angle, side of DEF. Or an angle, side, and an angle. Angle, angle, side refers to 2 angles and a side across from one of the angles, and the last one is called hypotenuse leg. Basically, if you have a right triangle or 2 right triangles and their hypotenuses are congruent and one of their legs are congruent, corresponding legs are congruent, then the triangles are congruent. So this may seem kind of challenging at first, but it gives you a little bit of a insight in terms of what you're going to see next school year. So let's start with number 12. Number 12 says you have this picture. Well, actually, you're given some information. AB is congruent to DE, and DB is congruent to AE. And you're trying to prove that the 2 triangles are congruent. Triangle ADB and triangle DAE. And here's what the diagram looks like. Here's triangle DAE. And then here's triangle ADB. And this is C. So we set up what's called a 2-column proof. Any statement you say in the first column, you have to back up with a reason in the second column. So, for example, we want to get one of these 5 ways of proving triangles congruent. Don't stress about which one it is, just take the information and go with it. Let's see what we're given. AB is congruent to DE. AB and DE. So that gives us a triangle on, let me highlight these, ADB, this red triangle, and then, see if this works, this other triangle, DAE, this darker one. So that's our first statement. AB is congruent to DE. The reason that they're congruent is it's given. So we have a side of triangle DAE congruent to a side of triangle DAB. So let's keep going. Next, DB is congruent to AE. That was also given to us. Let's see. So DB is on the red triangle. So I'm going to actually put a little bracket to show that this whole side is congruent to this whole side. And we'll put 2 slashes. All we need to get the red triangle congruent to the black triangle is another side. We could use side, side, side. maybe the angle in between the two sides, and we could use side angle side. I don't think these are right triangles, so hypotenuse leg is out. There's, if you notice, if I separated the triangles, DA is a part of both triangles. Sometimes it's beneficial to take a moment and separate the triangles. DAE had that, and then triangle ADB looks like this. DA is the same side. So something is congruent to itself. That property is called the reflexive property. DA is congruent to DA. That's called the reflexive property. And if you look, we're done with this proof because we have three sides of a triangle congruent to the corresponding three sides of the other triangle. So we simply write our last line. Triangle ADB is congruent to triangle DAE, and that is called side, side, side. You could abbreviate by writing SSS. Now, sometimes it's not that simple. Sometimes you have to use multiple definitions and rules to prove that sides are congruent. So that's what's involved in number 13. Number 13 says, you're given GJ bisects FH, and also FH bisects GJ. And this is the diagram. So this is GFK HJ. And we're trying to prove, of course, that triangle FGK is congruent to triangle HJK. We'll make our two-column proof. Now, they did not give us any congruent parts like in the last example, but we have to use our knowledge of words and vocabulary to help us out. The word bisects is very powerful. It means cuts into two congruent parts. So if GJ is bisecting FH, that means that these two parts that it's cutting would be congruent. So let's first write our given. GJ bisects FH. That's given. And that word again means that it's cutting FH into two congruent parts. FK is congruent to HK. And you just simply write down the definition of a segment bisector. And we're on our way. We have a side of triangle FGK congruent to a side of triangle HJK. Now likewise, it says FH bisects GJ. That is also given to us. So what that produces, similarly, if FH is doing some bisecting as well, that means that these two parts are congruent. So GK is congruent to KJ. Again, by the definition of a segment bisector. Words are so important in geometry. Bisector. Now we're almost there. We have two sides of this triangle congruent to the two sides of this triangle, but we've run out of givens. I don't see the use of reflexive like we did on that last question. But one other really important idea in these questions is when you have two lines or segments that are intersecting, we talked about this in another lesson, these angles are congruent. They're called vertical angles. Remember the day we talked about this diagram? These were vertical angles. So we could say, first of all, we got to present these angles. Angle GKF and angle HKJ are vertical angles. Why? Well, because intersecting lines produce vertical angles. And then we could say angle GKF is congruent to angle HKJ. Vertical angles are congruent. Now finally, we could say that these two triangles are congruent because of side angle side. So I'm running low on room here, so I think I'll just put it over here. Lot number 7 would be this. And the reasoning is side angle side. Let's do one more. All right, this is number 16. Number 16, I think I'm going to just talk you through. So on this question, it says C is the midpoint of AG. So what that means is if C is the midpoint of AG, that means that these two segments are congruent. Also, if HA and GB are parallel, HA and GB are parallel, that means that this angle and this angle are alternate interior angles and congruent. Also, it means that these angles are alternate interior and congruent. And then if you look, we have two angles on a side across from an angle, congruent. So these two triangles would be congruent by angle, angle, side. So I know I went through that kind of quickly, so I'll say it one more time. Since C is the midpoint of AG, you could say that CG and AC are congruent. Since HA and GB are parallel, that means that these angles would be congruent because parallel lines from our previous lesson produce alternate interior angles that are congruent. And then if you look, we have two angles and a side, and again that side is across from one of the angles, congruent to two angles and a side. So that's angle, angle, side that you would use to say why this is congruent. So if you need further help, this is kind of a challenging topic, please attend the Google Meet and have a good day, guys.